Hey there, Algebra 2 students. Today I want to go over the 9.4 homework, at least 9.4a, and answer a few questions. All right, number 1 said to determine whether the graph represents a periodic function, and if so, identify the period, and most of you had no problem with this. You recognized that yes, this is a periodic repeating function, and the period is 2 because the distance between, like from valley to valley, is 2 units, or from peak to peak is 2 units. So it's yes, the period is 2. The next question was similar. Determine whether the graph represents a periodic function, and if so, identify the period. And we have this wavy function, but it gets smaller and smaller and closer to 0. And so this does not represent a periodic function. And most of you had no problems with that. Let's move on to question 3. It said identify the amplitude and period of the graph of the function. And so we have this function here. It looks like a sine function because it goes through the origin, right? It goes up to +1 and down to -1. And so there's no change in the amplitude. The amplitude is 1. But from, let's see, they don't show us 2 peaks. They also don't show us 2 valleys. So we have to follow one complete cycle, and that takes us from 0, 0, up, down, and back to 0. And they didn't write the scale. The only point that they noted was this 2 pi. So we need to extend that out. It looks like each tick mark would represent pi. So this is 2 pi, this would be 4 pi, this would be 6 pi. And so the period of this function is 6 pi. Let's look at this question here, question number 4. It says identify the amplitude and period of the graph of the function. Here, the distance between peak to peak, from peak to peak, is pi units, and so the period is pi. And notice, so they only gave you a 2 here at that one tick mark, and then they left this other tick mark unlabeled. And so you need to realize that each tick mark represents 2 and not just assume that that's a 3. So this would be 4 and this would be -4. So it goes all the way up to 4, all the way down to -4. And so the amplitude is 4 and the period is pi because the distance from peak to peak is pi. All right. The next one I want to look at is, well, number 5. It says identify the amplitude and period of g of x equals 3 sine of x. Then identify the graph of the function and describe the graph of g as a transformation of the graph of its parent function. So the 3 in front of the sine of x tells us our amplitude, right? So our amplitude is just 3. And the period is determined by whether or not there is a number in front of the x right there, and there is no number there. So the period stays the same. The period is 2 pi. So we're looking for a graph of a sine function that goes all the way up to 3, down to -3, and its period is 2 pi. Now there are a lot of options here, right? You look to see if the amplitude, they all are going up to +3 and down to -3, so we can't rule out any of them that way. But we know that this is a sine function, and sine functions typically go through the origin, right? If there's no horizontal shift to the left or to the right, the sine function goes through the origin. And if there's no sign change, it's going up through the origin. So this goes through 0, 3. That's more like a cosine function. This goes through -3, 0, -3. That's more like a negative cosine function. This function, this one over here, goes through 0, 0 as well, but it's going down from left to right. So that's sort of like, it's like a negative sign function. So our answer, this first graph, is our best choice, right? It goes through 0, 0. It's going up to 3 at pi over 2, and it completes a full cycle by 2 pi. So the first option is your answer there. But then we're not done. You need to describe how is it related to the original sine function, right? Well, this one is a vertical stretch. The amplitude is 3, and so it's a vertical stretch by a factor of 3 of the graph of f of x equals sine of x. We've just got 2 more problems here. The next one said, identify the amplitude and period of g of x equals cosine of 3x. Then identify the graph of the function and describe the graph of g as a transformation of the graph of its parent function. So the amplitude is 1 because there is no number in front of the cosine, right? And so there's an invisible 1. That tells us our amplitude is 1. To find the period of the function, we take 2 pi and divide by the number right in front of the x. So we take 2 pi and we divide it by 3. And so the period of the function is 2 pi over 3. So we're looking for one complete cycle between 0 and 2 pi over 3. Remember, this is a cosine function, so it starts at the top, right, at 0, 1. This one here starts at 0, 0. It does not start at 0, 1, and so I would nix this one for that reason. This one goes through 0, 1. All right, what is the period of the function? It completes one cycle by pi over 3. That's too fast, right? This one has a period of pi over 3 and not 2 pi over 3. Let's look below here. This looks good. This one right here, because it goes through 0, 1, like a cosine function should, and there is one complete cycle by 2 pi over 3, and I don't have this one marked, so we'll mark it now. That is our answer. This one goes through 0, 0, so that is not ideal. And this is, how does this relate to the original cosine function? Well, it is a horizontal shrink, right? Because the period has gotten smaller horizontally. So it's a horizontal shrink by a factor of 1/3 because the original period is 2 pi, but this is now 2 pi over 3. So it's been multiplied by 1/3. Okay, and that brings us to our last question, which is identify the amplitude and period of the sine of 2 pi x, then identify the graph of the function and describe the graph of g as a transformation of the graph of its parent function, which would just be sine of x, right? Well, you've got sine of 2 pi x. There's no number in front of the sine, and so the amplitude is 1. And we would take 2 pi divided by the number in front of the x, which in this case is 2 pi, to find the period. So 2 pi divided by 2 pi is just 1. So the period is 1. So this is a sine function. We're looking for something that goes through the origin, through 0, 0, because there's no horizontal shift yet. And it goes up to 1, down to -1. And there's a complete cycle between 0 and 1. This only has half of a cycle. And it starts at 0, 1. This one goes through the origin, but again, has only half of a cycle. This one starts at 0, 1. Yes, it has one whole cycle, but this is a cosine function. And that leaves us with this last option here. It goes through 0, 0, and there is one complete cycle between 0 and 1, and they extend it out to 2, and you can see there's another whole cycle between 1 and 2. And so this last option is our graph. And then they want to know, is the graph of G a vertical shrink, vertical stretch, horizontal shrink, horizontal stretch? It's a horizontal shrink, right? Because the period is shorter than 2 pi. 1 is smaller than 2 pi. And it's divided by or multiplied by 1 over 2 pi. That's the factor of the graph of f of x equals sine of x. And it's 1 over 2 pi because we multiplied it by 1 over 2 pi, right, to get 1. All right, those are some answers to your first homework on section 9.4. I hope this helps you as you continue to delve into 9.4. If you have any questions, make sure you ask them, and I hope that you are all well. We'll see you next time.